Hi, Jermaine here, and in this series of videos, we're going to be talking about code generation in Dart. So when we talk about code generation, we're essentially referring to tooling that helps us to automatically produce code that we would otherwise have to type out manually by hand. So Dart has actually got some tools to help with that, but then there is a lack of documentation and it's a bit esoteric trying to understand it and how it works. So I hope to cover code generation and hopefully help you to understand it better. Let's begin. So code generation is possible through a package from the Dart team called Build. And what Build does is it allows us to, as it says here, define an interface for creating a builder. So what is a builder? Builders essentially allows us to define the business logic for generating our code. So that is where you would have your logic that does the actual generation of code. Build doesn't work on its own. Although we've defined the business logic, we need an array to run this logic we're going to be writing. And that's where build config and build runner comes into play. Let's just create a project and write our first builder. We're going to start by creating a new folder. We'll call it code generators. And in here, we will use stagehand to scaffold the files and folders for a console-based application. What we need to do afterwards, once we've generated our files and folders, is to come to our pubspec.yaml file and we'll update our dependencies and dev dependencies list with our build packages. So that's build config, and build runner. Once we save our changes, go to the terminal and run the pubget command, or if you're using the Dart extension for VS Code, that should run automatically. And while that's happening, we're going to come to our lib folder and then we'll create a new folder under lib called src. That's where our builder implementation would go. So under lib source, let's create our first builder. And we'll call it CopyBuilder.dart. And in CopyBuilder.dart, we will import our build package. We need to implement this abstract class in order to define the business logic for our code generation. So we will create a class called CopyBuilder, which implements the builder abstract class. This means that we need to define two methods, which is build and build extensions. So if we come to the build abstract class, we've got our build, which is where we write the logic to generate code. And then we've got build extensions, whereby we'll define the file extensions we are looking to match and the extension of the output file that will be created. We need to implement these two. So I'll copy this one and I'll place it here. So it's a map type and it's a getter called build extensions, and let's mark this as override, and this build extensions will return a map object in which the key is a string. So in this case, .txt is the file we'll be looking for in our project, followed by an array of strings, and each string in the array is the final file that we're looking to produce from each of these matches. So that brings us to the second member we need to implement, which is our build method. So we use the override annotation, and then our build method signature returns a feature of void, and then it's called build. And while this build runs, it gives us access to what's known as a build step. And essentially a build step contains the logic, as it says here. It represents a single input ID. We'll look at that in a bit. The build step also represents the logic around resolving asset library and the ability to read and write assets as allowed by the underlying build system. So what that means is that with a build step, we're able to do things like reading files. We're able to also write files as well. So firstly, what we'll do is we'll retrieve the currently matched asset. This is exposed in our build step via the input ID property. So the input ID as part of the build step is an object of type asset ID, and asset ID represents each file that gets matched. So it's an object wrapper representing the text files that get matched, and it contains details such as the file name and the file path and various other things. So if I'm to set this to asset ID and I go to definition, it's got details like the name of the package containing this asset, the path to the asset or the file path. It's got the extension and various other things. It also has methods to add an extension or change an extension and so on and so forth. Once we've retrieved the currently matched asset or txt file in this case, because that's what we're matching for, we can now create a new target. Essentially, we'll be creating a new asset ID, which is based on the old one. So which is based on the current one, this one. So let's do that now. So we'll do var copy asset ID, and then we'll do input ID dot change extension. And then here's where we'll set our new extension, which is copy.txt. So it has to match this one here. And then secondly, what we'll do is we will retrieve the contents of the current asset, and then we would place that into the contents for this new asset that we are creating, this new file that we're creating. So let's retrieve the contents of our current asset by using build step to read it. So we do await build step dot read our string, and then we'll pass in the current input ID. So now that we've retrieved our contents, we can write out our new asset, which means we can do await, we can use our build step object again, and then we'll call write as string. And for our ID, we will pass in the new asset ID, and then contents, it will contain the contents of the current matched asset. So let's save this file. And then now that we've created our builder, secondly, we need to register it. So we'll come to code generators.dart, get rid of this calculate function, and then we will import our build.dart file. And to be conventional, let's give it a library name as well. Just call it code generators. And once we've imported our build.dart file, we also need to import our builder. So we do package, and then the name of this package, which is code generators. Then we'll look in the source directory in copybuilder.dart. And this package name is based on the name that is set here in our pubspec.yaml file. So whenever I reference the package, it points to the lib directory in this folder, and then we're looking in our source, and then we're looking for copybuilder.dart. All right, we need to create a top level function that returns our builder, and the name of our top level function, in this case, we'll just call it copybuilder. And once we've created copybuilder, we just need to return an instance of our copybuilder class. So let's save that. Now we're able to move to generating. And in order to do that, we need to define a builder YAML file, which is responsible for essentially describing the configuration for our build. So I'll show you what that looks like. So under here, we'll create a new folder. We'll call it, a new file. We'll call it build.yaml. And we've got to make sure build.yaml is inside code generators. So I'll move inside there. And in our build.yaml file, we need to start by defining our builders, the configuration for our builder. So start by using the builders keyword, and then each builder takes in a builder name. So in our case, we called it CopyBuilder, and we need to define an import, which is the file that registers our builder. So in this case, it's this one. So do package code generators dot. And then we need to define our function that we registered. So that's under the builder factories property, and that takes in an array. And here we just need to define, we just need to say CopyBuilder, which is this name here. So essentially what we're telling our build runner, which will be using this build YAML configuration, is that it's going to import this file here and then it's going to run this function. Next, we need to define our build extensions here as well. So this takes in a map of key string and then the value is an array. So basically we're repeating that over here in our build YAML file. So it will be .txt for the key, and then for our value we're producing copy.txt. And then the next configuration we need to define is where we want the output to be placed. So the configuration is called build to, and you got several values. So you got build to source, which is essentially the output would be placed next to the file the output was generated from. Or alternatively, you could put cache, which will generate the output in a hidden cache directory. So you won't actually see it here because it's in a hidden cache directory. But for this example, we're going to build to source. The next configuration we need to define is where to apply this builder. So that comes in the form of an auto apply configuration key, and it's got several values such as none, dependents, or packages, or root package. So for this one, we'll just say root package. So that would apply this builder to this current package. So let's save this one. Lastly, what we need to do is, in order to actually set up this builder to run, we need to define a build target. So build targets essentially allows us to apply our build to groups of files. In this example, we're only looking at .txt files, but let's say if you had multiple builds which targeted different files, then you configure a target for each subset of files you're trying to match. So since this example only targets txt, we'll define one target for our txt files. Each target takes in a key, which is normally in the form of the package name. So the target package name, which will be code generators, and then the name of the target, which we can call code generators. And then in here, we will define our builders for our target. And then for each of our builder, we will define it as such. So we'll target our current package, so code generators, followed by the name of the builder we wish to use. So it's CopyBuilder, this one here. And for now, we will set enabled to true. So let's test this actually works. In, let's say, lib, I'll create a new file and I'll call it example.txt, and I'll add some lorem ipsum text. Okay, so if all is right, you should be able to cd here, and then let's run our build. So we do pub run build runner, and then we do build. Okay, let's run it. Okay, so we're getting an error. A value of type builder function can be assigned with a variable of type builder function builder options. Yeah, so that's because for each of these functions, when the build process is running this function, it actually passes it an argument of type builder options, which is essentially a map of options that we are able to pass to our copy builder. So currently we're not doing that, but for now, just put that here and run the command again. Okay, so our build is successful, and we can see right next to example.txt, there's an example copy.txt. If you got to this stage, then we have successfully implemented our first builder in our first code generation process. We can modify this output a little bit by coming here, and then rather than just outputting the contents, why not add a timestamp to it? So I'm going to use a multi-line string and then produce a timestamp by doing datetime.now, then followed by our file's contents. And let's add some lines before and after. Okay, let's run our build again. Okay, because the build is running again, it's deleted what was generated earlier on in order to generate a new one. So it successfully generated it, and when we click on this, we see our timestamp there, followed by the contents of our file. So I'm going to recap on what I've done so far. If we come to the pathspec.yaml file, we are using these 3 packages here. So the build package exposes the builder abstract class, which allows us to implement our own builder, so the business logic for generating code. And then we've got our build config package. This is able to parse the instructions, the configuration we've put in our build.yaml file. And we've got the build runner, which is what spins up the build process. And if we come to copy.builder, as I mentioned earlier, here is where we've defined our own builder using the builder class exposed by the build package. And in codegenerators.dart, here is where we are defining the function that will be invoked by the build runner package when it's running the code generation process. I know I said earlier that here's where you would register it, but that's not necessarily the case. You would register it in the build.yaml file. So this brings us to the build.yaml file, and here's where we register our builder that we've defined. Furthermore, we define our build targets for the different types of files we'll be generating. So for now, we're generating a .txt file, but then we could be generating other types of files and so on and so forth. So for now, we're generating a .txt file, but we could be generating various other files, basically. So in here, we've defined a target based on the copy builder. For now, I've just set enable to true, but then you can set various options, such as, for instance, generate for. And here you could define a list of directories you want the build tool to search for matching files. So in this case, we could just do lib and star. This uses glob pattern syntax. So this ensures that the build runner would only look for and generate for files located in the lib directory. So if example.txt was somewhere else, then it won't generate. It will just ignore it. Okay, so let's save and generate this one more time. And to prove this works, I'm going to create a new folder in here, call it web, and in web, let's put a new text file called ignore.txt. So this text file will be ignored. So let's save that, close, and let's run our build script again. Okay. So as expected, example copy.txt is generated for our example txt file in the lib folder, but then in our web folder, this is ignored. And if I'm to get rid of this configuration, then it should generate for the web folder as well. So let's try that. And there we have it, ignored copy.txt. There's a bit more configuration for targets and builders, which can be found if you go to the GitHub page. So if you go to github.com/Dartlang build and then click on build config, and in here it's got a short summary of the build.yaml file and a bit more information about configuring your build. And then if you want to know the full format, come to this file, docs build YAML format, which has got all the keys, including the expected values and what the defaults are. But yeah, to be honest with you, this will probably take a couple of goes to get used to this, as it did for me. It took me reading this over and over again. But aside from the example that I've shown so far, in fact, I got this from the Dart examples that they've got for build. But I'm going to end the video here. Thanks for watching. And if you enjoyed what's been presented so far, do subscribe, do click the bell notification icon so that you're updated when new content is released. Also, any feedback you've got for me, just let me know down in the comments below. If you've got any questions, let me know down in the comments below and I will try and respond. Thank you.